Well, folks, it's Monday. We haven't finished our Sunday set. It wasn't a Sierra Hotel 1 Tango set, not in my opinion anyway. It's a low TX40 I was doing. We just ran out of time. I'm trying to battle on with the organ. I've got church services to play for, etc. And it wasn't straightforward. It had the golden screwdriver, but it's nearly there. So we're going to do a customer set, because I did say I'd look at it on it's lost its front, hasn't it? The last thing you want to fall on the floor is that. Yes, I think we'll put a dab of glue on that. So I've just put it on one of Mr Chippie's microfiber cloths, because this is pretty good condition, especially with the chrome front. So the Binatone 5-star, I think is the best Cybernet 134 mobile there is. One of the appeals to me is the loudspeaker. You can select internal or external speaker from the front panel without just having to unplug the thing at the back. That's really good. And it's got the bigger speaker. It's got the 3.5-inch speaker, which the Rotel 240 doesn't. But they could be a bit garish or Americana, you could say, couldn't you, of the styling. So some people may be put off by the styling. And there was a time that when, if we go back in time, before I was doing these videos, when you could buy a Rotel 240 for 35 quid, well, you'd get one of these for a tenner. It was like, that was the difference. And it's the same with the Fidelity 2000. You know, you could get, let's say, an equivalent model, the Rotel 230. You'd probably have paid £35 for one of those, and you'd have got a Fidelity 2000 for £7 or £8, because it says Fidelity on the front, and people just don't seem to take into consideration that Fidelity just order things from to be manufactured abroad, and it's the same set as other badges. We had this with video recorders from Dixon's in the 80s. I remember the top loader, the VR705, which they did, also appeared as the Amstrad 7000. We're talking about when VHS video recorders were just under £1,000, and Amstrad did the £599 VCR 7000. Well, this was also the Seisho VR705, and it was, I think it was £379 from them, probably 6 months later. But it was manufactured for them by Orion, and it was good. The next model I did was manufactured by them by Funai. It was absolutely rubbish. So you know, different models, and this is where you have the Fidelity 1000 made by Great, which is not like the Fidelity 2000, and the Fidelity 2001 isn't really as good as the 2000 in my opinion. Right, I'm going to open this up because I'm just looking for silliness, just in case. But I wouldn't expect that. And then we'll go through how it works. I've got exactly 15 minutes. It's already 6 o'clock. I have to be somewhere at 6:30. I'll tell you what, we'll just leave that front off. When I disappear off, I'll put a dab of glue on that. So this is an end user, and we don't do many sets for end users. In fact, we didn't do any until COVID struck. So I don't have that many sets come in from individual end users, because I don't want them to kind of, we charge very low prices. They're the same prices we charged in '95. It's about half minimum wage it works out at, and we just kind of do it as a favour. What I don't want to happen is some end user sending me a box of 30 sets they bought off eBay, sorting them all out and then flogging them for a profit, because I'm here to help people with their personal collections, not necessarily to profiteer. If they want retail prices, they can have retail prices. Do as many as they want then, but it'll be 4 times the price. Right. So this is his bite at the cherry. He gave me a list of what I thought was going to be the best. So have we got PA, or is it on one of these switches that I now need to put the escutcheon or inlay back on? We use Bostik adhesive, and there's one here on the bench. I'm going to be very sparing. Oh, it's got some blocked up thingy, just like you'd expect. All I want to do is to run some tests. We'll have to come back to that. Find the switch. CBPA, it's in PA, so we'll plug our mic in. So standard Cybernet 4-pin mic. Testing 1 2, testing 1 2. Right, that works. So we've got the meter lamp working, and we've got PA working. So switch it back to CB. On high, we're on internal speaker. We'll just make sure it sounds like it works. It does. Well, now we'll go to external speaker, put it to channel 20. So I think we're done with that. We'll plug the test instrument speaker in, and we'll plug the aerial into the test gear. Right, picture in picture on. Transmit 3-watt scale, not quite going across. So at 13.8 volts, it's drawing 864 milliamps. And it is 2.8 watts. Always add 10% to what I tell you because of this being a selective meter and really only reading what's within the band it's set to. So you know you get that screwdrivered Amstrad on which the person reckons he's doing 7 watts, and this test set will probably say it does 3 because the rest of it's on the aircraft band. Right, channel 40, 2.7 watts. Channel 1. That's wiggling about a bit, I don't like that. 2.6, that tells me the VCO is struggling. And on low power, we'll go back to channel 20. I'll have to bring that inlay again to see what switch is which. So low power on the short scale. Is doing 100 milliwatts. We'll just check the deviation. Wallow, 2.4. Probably about right. I'll come back to frequency because we are only just switched on. I'll go and do my chore in a moment, which means driving 8 miles away and coming back again. So what we'll do is disconnect the speaker let's look at that VCO. Starting on channel 40. Putting the escutcheon to one side again. With Allen's crocodile clip lead, we'll put an earth onto the test equipment with the Lidl multimeter, £16.99. We'll see where we are with this. So I want 4 volts. It's a little bit high. I'm a bit more concerned about the receive one. This is neither here nor there. So I'm a bit more concerned about the transmit one because it seemed to be not liking channel 1. So that's 4 volts. In transmit it's, well, it's nearly bang on. Back to receive. Now we'll go to channel 1. It's somewhere between 1.8 2.35, something like that. On receive we're well within that, and on transmit we're also within that, so that's fine. So go back to channel 20, we'll tune up the transmitter. Put that away. So we'll stay on the 3 watt scale. When I take out to low power, just see what the meter reads. It reads 4.5 at the moment. I've looked and there's no dodgy looking capacitors, which is nice. We'll start there. Now we need to do this peaking and hope none of these have been broken. So maximum, well, that's not fitting any of them, and it's the right tool, so that ain't good news. So we've got to peak these 3. We'll do it quickly because the transmitter can't sustain the power it can deliver for very long. I've said before, when I was doing business radio all day, the Olympic VHF AM high band set with a 60 watt PA, it was a 10 watt radio. It was really on top of the job. You had to turn the power up to 60 watts to tune it up, and it couldn't sustain it, so smoke came out of it. And my boss used to say, "You tune it for maximum smoke," he'd say jokingly. You had to do it within 10 seconds, or wait, and if you were struggling, you'd have to wait. So that is peaked. He's doing 4.6 watts. So now it's the yellow one clockwise for 4.4 watts, and the green one anti-clockwise, they say for 3.8 watts, but we're entitled to 4 watts, so we're jolly well having it. Not that it makes any difference, but we're going to have what we can have. So we've got 4 watts on channel 20. Let's see what we've got on channel 40. Probably 4.02 or something, and on channel 1, bang on the 4. So I can safely say that's really well balanced. Let's see if we can do the low power. Sometimes you've got a dirty preset. I think that's, I'll just go to channel 20 again. We'll just give that a spray. Waggle it around a bit. Sometimes they even open circuit. It's supposed to be 400 milliwatts, 0.4 of a watt, and there we are, bang on that. now gone back to full power, and the current consumption is now 1.107, which is very efficient. So we'll come back to the deviation. I've got to check it with the test set behind me, and I'll set the frequency when we come back. So we'll just set the meter. It's probably banging across now. That's the meter preset there. Yeah, it's banging across. Look how much power I'm doing, good buddy. It's banging across. Yeah, he's still doing 4 watts. That's the meter preset. Right. I'll be back in an hour and a half. Right, I'm back. So, we could do the frequency, I reckon, now. So we will. I'll put the camera, appropriate camera on. So it's 27,79112. It's 4.4, wasn't it? It's now 4. So it hardly needs touching. There we go. I'll just check the deviation with the test equipment behind me, because we're done with it then, aren't we? Rather than coming back to it at the end. It's very, very slightly high. But I want this set a particular way, so I want that to central position, then we're going to adjust it on that one. Wallow, wallow. That's it. Unplug my lead and plug it back into my Marconi test set. I've said before there's a quartz lock. Is it 2858, that one? 282. Right, so that's that done. Deviation. Right, now before we go in, we've put it on frequency, but we haven't touched any of the receiver, so that's what we're going to do now. So we'll set the signal generator. I want 27,79125. There we go. And put the SINAD meter on. We're going to discuss the detector. I've discussed this quite in depth on the low TX40, but this video is going to go out first. But we're going to discuss it on this one as well, so you see it several times. One of the I think it's one of the American ones has viewers has said about talking about the detector, so I will do. But I don't want to do it on a set which is unconventional, and I have to say the low TX40 isn't that conventional. This is. So we'll go over to the SINAD meter. Let's get some readings. Poltergeist mover. What it is, there's a computer printer on the bench that all the cameras are mounted on, and I say mounted on, they're not screwed down, they're heavy weighted down, and unfortunately the heavy weight's moving when the printer operates. I found out what it is. It's Mr Chippie's fault, I expect. So, turn the squelch down. If I put those fingerprints on, I better wipe them off with my t-shirt. Make sure that RF gains to 4. So straight away, we've really got very good sensitivity. I won't be improving on this, I can assure you. It's 0.21. .2. and 20 0.39. Squelch tight. I want it to be 100 microvolts. It isn't. It's 1 millivolt. That's too tight. Threshold. Set it on the radio. Signal generator back on. It's 1 microvolt. Speakers okay on this. Sockets are okay. Switches are okay. One of the pots is dirty. And it's mic gain. We'll do that in a second. So S9. We won't have time to scratchy corner this today. So if I put 100 microvolts on, we should have S9 on the meter. I can't see that, so change glasses. Wow, it's not far out, that. Wow, that is good. 65 microvolts. Right, so we'll tune up the receiver. So here we go with the detector. So I'm going to talk to Mr Chippie. Tango 21, Mr Chippie.
Tango 21, go ahead.
Yeah, Roger, we're going to demonstrate the detector on this Binatone 5-star that I'm working on. I'm on the test set on the dummy load, over.
Yeah, roger that. So I'll give you a quick count. 5, 4, 3, 2, 1. 1, 2, 3, 4, 5.
Right, roger on that. So, it sounds alright. He's 2 rooms away. He's on the Midland base station, so he can get me on just the dummy load. Right, so what we're going to do is we need to put... Well, what I'm going to do, I'm going to put 100 microvolts on. We'll look at this on the oscilloscope, and we'll see where it is. And I'm going to detune it. So I've got 100 microvolts. And the idea is to have a nice sine wave, not one that's lopsided and all that. So on this radio, the detector here, your FM chip is there, and so the detector coil is always going to be next to the FM chip, because it can be muddled up with IFs. That's 455 kilohertz, for example. IF is intermediate frequency for those. I don't want to be talking in code. So at the moment, that's the sound wave we've got. Now let's just adjust. Let's just see whether it gets better, because we're looking for maximum recovered audio. That oscilloscope is simply across the extension speaker plugged in. The test instrument, the extension speaker, and an oscilloscope are plugged in as a dead basic oscilloscope. It was brand new, 115 quid 3 years ago. It's a CRT oscilloscope. I bought a couple from China because I was scared that CRT oscilloscopes were going to disappear. I want the instantaneousness and no time lag, what they call latency. It saves me a lot of time and gives me more accurate results. So it's a very ordinary oscilloscope. That one's 10 megs, but equally it could be 1 meg. We're only looking at audio. So here we go. Do we get a bigger recovered audio? No, it was already spot on. Now what I'm going to do, we're going to turn it down, and let's just see what he sounds like now. Tango 21, Mr Chippie.
Go ahead.
Right, I want you to talk for about 15 seconds.
Yeah, roger that. Not how long 15 seconds from now, I'm not sure. But, yeah, what to tell you, I'll just count I think for a while. So 5, 4, 3, 2, 1, 1, 2, 3, 4, 5, 5, 4, 3, 2, 1, 1, 2, 3, 4, 5.
Roger on that, thank you. So, I've kind of guessed that while he was talking. He was just going quieter, but on a lot of radios, it'll go garbled or sound distorted, like talking as if you're a Dalek. So it's a good example, but it doesn't do extreme things on this chassis. So what we're going to do is we'll put the 100 microvolts back on, and let's see how close my guesstimate was. Wasn't quite there. So now we're going to go through the whole set, IF and everything. See, these can make it lopsided. Can you see it going to one side as the IF goes off frequency? I won't be surprised if the other one there does the same. The answer is to some extent. Those two are really going to affect it. Right, anyway, we're going to do the... Actually sounds awful now. So see if we get some more sensitivity. So we're now going to look at the SINAD meter. And we're moving that towards the... moving the needle to the left. Left makes it better. Turn the signal down till we've got about something like 4 or 5 dB. So there's a slight improvement on there. It's now waggling around 6. That one under the wiring. The extra one you don't get on the Rotel 220 in the York 861. You get an extra one with the base station version there. Now we're going to put a bigger signal on so we can see this more accurately. Quite a pronounced exact thing, that. Then this hidden one under here is about there. So we're done. So let's get a new set of readings. Okay, so let's see where we are now. So for 12 dB, we're round about there. It's 0.2, nearly 2.1. It's a little bit better than 0.21, but we'll put 0.21. For 10 dB, it's 0.2. For 20 dB, it's 0.3. I could say 375. I'm going to say 3.8. So really, I have altered it. I think this IF was slightly out, but and I brought some more sensitivity on that, but it's not showing. Once you get down to this level, not much is going to get better, is it? Certainly a new set. Not many new sets perform as well as this. Though I must say, in all fairness, that Thunderbolt T800, the factory preset radio, was somewhere down here, which amazed me. Right, let's do the squelch, and then we'll just talk to Mr Chippie again. So I'm going to turn the squelch to full. This may have altered. Let's put the attenuator on the screen. So 1, 3, 10, 30, 100. No, it hasn't altered. So we'll just adjust the squelch. That's where I want it. So now we'll look at it at the sensitive end, set the squelch on the radio to threshold, signal generator back on, and let's see where it comes in. And the answer is 0.88 microvolts. And now we've got 100 microvolts for that. So we'll put 100 microvolts back on the signal generator. We'll look at the S meters alignment. It's a little bit high now. That one. Remember, S9 is the only thing you calibrate them against, so all the rest of it can be anywhere, can't it? Not all meters read the same. So there we are, we're actually done. It works very well indeed. So I didn't have to do much to receive it. It was hardly off frequency. I mean, I could put this on with 4 or 5 test sets. They're all going to read slightly different, even though they're satellite locked. So it really I think the biggest thing is bringing the transmit power up to full 4 watts is been the thing on this set. Having the squelch where I want it. Jobs are good, and as they say. I'll put the lid back on. So there will be a low TX40, which we'll get on with tomorrow or Wednesday or whatever. Just wasn't time. I've got to go back in the organ workshop now. You know, when you're doing these organ jobs, which are thousands and thousands of hours, you know, like there'll be 12,000 hours on this job. You know, you've got to. I get up at 6:30 in the morning and do an hour before breakfast. You know, you go in at 8:30 and do another hour till 9:30. You've just got to get these jobs down, and that's why having the workshop within the grounds of my home. That's not the screw out of this set. That's an old rusty one out of the low TX40. Nearly fobbed him off with an old rusty screw there. So I put a Binatone 5-star screw in that side. Turn the volume down so you're not all annoyed. So what a lovely radio. We've had quite a few really good ones of these recently, and we also have some rather good Harrier CBXs as well. I'll actually glue the thing on tomorrow before we do the on-the-air test. On-the-air tests are always done between, well, we try and do them at 7:30, but we don't do them earlier than 7, and we never do them later than, you know, like 10 to 8. So we've now gone beyond that time scale. So there we go. So unplug the speaker, switch to internal. And we'll plug the aerial in. So it's just beyond probably about 8:10. Monday evening. One Nana Roger. Tango 21, Mr Chippie.
Tango 21, go ahead.
Just checking it sounds wonderful.
And does it?
Yes, I'm just going to demonstrate this tone thing.
Yeah, Roger, so you want me to give you a count again? 5, 4, 3, 2, 1, 1, 2, 3, 4, 5.
Roger, thank you very much, that's it. You can switch off now.
Yep, Roger, 10, 10.
10, 10. Excellent. Roger. Okay, well we'll put that as an on-the-air test tomorrow when I've glued that escutcheon back on. So I hope you enjoyed that, and a little bit of a demonstration with the detector. We'll do that on 1 or 2 sets so you get to grips with what's going on. So thanks for watching Binatone 5-star from 1981, which uses a Cybernet 134 chassis.